Good morning, children. Today we'll be starting with chapter number 3, and the name of the chapter is Separation of Substances. Before we start with the actual separation of substances, we have to have a brief idea on what matter is. So matter is something that has a mass and occupies space. So everything we see around us is matter, right? Now this matter can be grouped into two groups: pure substances and mixtures. So first, pure substance. Pure substance is one which has uniform composition and properties. It is pure and composed of single units and cannot be separated by physical means. Like oxygen that we breathe in is a pure substance because it is made up of only oxygen atoms. Water that we drink is a pure substance because if you look at water, it is made up of only water molecules, that is hydrogen and oxygen, so which makes up H2O. Pure substances can further be grouped into two groups: elements and compounds. Elements. The first type of pure substance. There are nearly 120 elements known to us, out of which 90 elements occur naturally. The remaining are prepared in the laboratory. Examples are hydrogen, nitrogen, oxygen, iron, gold, silver, helium, neon, etc. and it goes on. Coming to the characteristics of elements, an element is made up of only one kind of atom. That means iron is made up of only iron atoms. Element oxygen is made up of only oxygen atoms. Alright, similarly, element gold, it is made up of only atom gold. So every element that we see is made up of only its own kind of atom. Secondly, it cannot be broken down into simpler substances by any physical or chemical process. We cannot break it up. And the next is, elements may be classified into metals, non-metals, metalloids, and noble gases. So now we know that all elements are made up of atoms. But we also have to know when similar atoms combine together, they form molecule. That means when one oxygen atom O combines with another oxygen atom O, then it forms O2. That is one molecule of element oxygen. Similarly, when one hydrogen atom combines another hydrogen atom, similar atom, then it forms H2 and we call it as hydrogen molecule. So that means when atoms combine, they form molecules. Now elements can be composed of either one, two or many atoms, similar atoms. Alright, so this chart shows that when an element has only one atom, we call it as monoatomic, like helium. When it is made up of two atoms, we call it as diatomic. Example, oxygen. And when it is composed of more than two atoms, we call it as polyatomic. So based on the number of atoms, it can be triatomic like ozone, tetraatomic like phosphorus, and octaatomic like sulfur. Okay, now coming to the next type of pure substance, and it is called as compounds. So a compound is made up of two or more elements combined in a fixed ratio by weight, and it can be broken down into elements by chemical methods only. So that means when you have a compound, it is always made up of two different elements, but they are to combine in a proper ratio. Like for example, water, that is H2O. So for water, we have two different elements, hydrogen and oxygen. So when we have two hydrogen and one oxygen, only then we get water. So it has to be in a fixed ratio, right? And when we break down the compound water, we get the elements hydrogen and oxygen back. Similarly, carbon dioxide, CO2, is a compound made up of carbon and oxygen, one carbon and two oxygen. When we break carbon dioxide, we get the elements carbon and oxygen. Coming to the characteristics of compounds. Number one, it is homogeneous in nature. That means it is uniform throughout. So if you take a glass full of water, water is H2O. So this H2O is present throughout the volume of the glass. Whether you take water from the topmost portion of the glass or from the bottom or from the central portion of the glass, you will find only H2O, that is hydrogen and oxygen, which makes up water. So we call it as homogeneous. It has a fixed composition by weight. Every compound that you have, it has to be in a fixed proportion. All right, like carbon dioxide, you have to have only one carbon and two oxygen atoms to get carbon dioxide. Ammonia, NH3, that means one nitrogen, three hydrogen atoms only, then make up ammonia. Water, H2O, two hydrogen and one oxygen atom make up water. Beyond that, if you write H2O2, that is not water. Only H2, two hydrogen and one oxygen is water. Compounds are formed from its elements by chemical reaction. So for a compound to be formed, the elements which are there, they need to be chemically bonded. You cannot just keep hydrogen in one test tube, oxygen in another test tube and wait for water to form. That will not happen. The two, hydrogen and oxygen, they have to combine chemically to give us water. Next, the properties of a compound are different from those of constituent elements. So we can take the example of water only. Now if you see, water is made up of hydrogen and oxygen. Now hydrogen is a gas, oxygen is also a gas, but when you see water, it is liquid, right? So that means the properties of the compound water is entirely different from the properties of the elements which is making up water. Then a compound has a definite melting and boiling point. Every compound that we have, like boiling point of water is 100 degrees Celsius. So that means each and every compound that we come across they carry their own particular melting and boiling point. Mixtures. A mixture is formed when two or more substances are mixed together in any proportion such that they retain their individual properties and can be separated by physical means. For example, air is a mixture of gases. Now in a mixture, the components that make up a mixture can be in any number. So example, like air, we have many gases like oxygen, hydrogen, carbon dioxide, argon, water vapor, dust particles. All these components together make up the air, and they can be easily separated by simple physical means. Now if you see, each and every component of air has its own particular properties. Like oxygen is used for the process of respiration, carbon dioxide is used by green plants for photosynthesis, right? So similarly, if you see in a classroom also, let's take the example of class 7C. Class 7C is a mixture of boys and girls. Now they are in number. It's not any fixed particular number of boys and girls. It is unequal number of boys and girls in the classroom. Now every individual component of that classroom 7C carry their own particular properties. Like Karma Kalsang has her own property, right? Similarly, Chidanlamu has her own property. Kalsang own property. So they retain their individual properties and they can be easily separated. Based on the state of the component of the mixture, we can have number one, solid mixture. Example, we can have rice and pulses. Mixture of rice and pulses can be an example of solid mixture. Number two, solid liquid mixture, like keeping sand and water can be an example of solid liquid mixture. Or salt and water, sugar and water, sawdust and water. Number three, liquid mixture. So it could be our milk and water, tea and milk, all right, or lemonade, all right, where we have lemon juice and soda. So these are different types of mixtures. Depending upon the constituent particles, mixtures can also be classified as homogeneous mixture and heterogeneous mixture. When we say homogeneous mixture, it is a type of mixture in which the constituents are distributed uniformly. For example, sugar solution. When we dissolve sugar in water, we get sugar solution. Now, for the sugar solution, if you take from any portion of that mixture, it will taste the same. So that means it is distributed uniformly. So we call it as a homogeneous mixture. The next heterogeneous mixture is a mixture in which its constituents are not distributed uniformly. For example, sand in water. Now if you dissolve sand in water, you'll see a clear layer of sand below, alright, which settles down, and water on top. So that means you can easily identify the two different layers of the components which make up that mixture. So such type of mixture is called as heterogeneous mixture.